Hi everyone, this time we are going to talk about standard integrals. So the first standard integral is our x to the power n dx, and that integral value is x to the power n plus 1 over n plus 1 plus c. And you have to remember that this formulation is valid when we have the derivative of this base term next to it. So somehow the derivative of x with respect to x is 1, so somehow this one is present over here. So that's why this formulation is valid, x to the power n plus 1 over n plus 1. And this formulation should be valid for all n except when n is not equal to minus 1. So we will have a look on the case when n is equal to minus 1 later on. So for the time being, we are just focusing over on this integral, x to the power n dx, and the integral is going to be x to the power n plus 1 over n plus 1. We can generalize this criteria to any function, but we need to make sure that the derivative of that function should be next to it. So because the derivative of this function is next to it here, so this formulation is still applicable, and you can apply f of x to the power n plus 1 over n plus 1 plus c. Okay, so one thing you need to remember that you can verify this result by using some substitution. So let's say we need to verify this result. So let u equal to f of x. So the derivative of u with respect to x is just derivative of f, which is f dash x. So if you sub in all this substitution in terms of u, that's going to be u to the power n, and this f dash x is going to replace with du over dx times dx, and this is nothing but u to the power n du. Okay, and this expression is exactly the same as our first formulation. So instead of x, we have over here u, and then definitely you can apply this rule because the derivative of this term is next to it, which is 1. So which is u to the power n plus 1 over n plus 1 plus c. And when you substitute back u as f of x, so that would give you f of x to the power n plus 1 over n plus 1 plus c. And no wonder n should not equal to minus 1 for this case as well. Okay, so that's the general expression what we can implement in terms of the power n. So you need to remember, so if you have a function to the power n, so its derivative should be next to it, then you can apply this formulation directly, or you can simplify that one by using substitution as we have done over here. Again, so let's see some examples to implement this rule. So we have, let's say, an expression of the form x to the power, let's say 7 dx. So it is exactly the same thing what we have in formulation 1, and the derivative of that one is somehow is present here 1. Okay, so we can apply this rule, 7 plus 1 over 7 plus 1 plus c. That would give you x to the power 8 over 8 plus c. Okay, now let's have a look for another example. Suppose we have the function of the form 2x plus 1 to the power 11 dx. Okay, so one thing you can observe here, this function has a derivative 2, which is actually not here. So, but the derivative of 2x plus 1 is 2. So because this is a constant, so we can manage to compensate this derivative here, which is 2 by 2 times dx, if you want to apply the rule 2. Okay, so that can be written as 2x plus 1 to the power 11 2 dx. So because the derivative of this term is next to it here, so you can see that you can apply this second rule over here. So because this is your function fx and its derivative is next to it, so we can directly apply the power rule, which is 11 plus 1 over 11 plus 1 plus c. and you can write down further simplification. 2x plus 1 to the power 12 plus c. Okay, so you can simplify that one by using the substitution, but if you don't want to apply the substitution, so you can do that one, but you have to just make sure one thing: this can be done only, this multiplication or division what we have done over here, that's only possible when we have the derivative constant, and you can manage this one, right? So hopefully that you understand the first integral, standard integral, and hopefully that you understand these two examples. See you in the next video. Thank you.